Hey, this is Dan from Abbott University, and this video is actually from my friend Paul, who has got some calculus homework, and since it's early in the course, as is often the case with calculus classes, there is a lot of kind of review of pre-calc and algebraic concepts and things like that that you have to make sure that you understand before you dive into the official calculus stuff. But anyway, I've got 4 problems here that are really not too hard in my opinion. So let's just get right to it. So first problem is find composite functions of f, g, and g, f. Now, in the actual review guide, this O-shaped thing is a little bit smaller, but I think it's just important to understand that this FOG looking thing, that's sometimes written as this, right? And in my opinion, this is a little misleading. This could be misconstrued as like multiplying or something like that. Whereas this is a little bit more representative of what's actually happening when you're dealing with composite functions. And I'm going to explain why in a second. But nonetheless, let's just understand that this really is that. And this is this. All right. So as far as this one goes, what that basically means is f is the overarching function. That's the wording that I use in my brain, the overarching function. The fact that the f is kind of on the outside, that means that f is the big picture of what's going on. All right? F is the larger context within which this smaller kind of activity is occurring. So what that means is we want to look at the function f of x, which is sine x. Okay, so sine x is the larger context within which the smaller activity is occurring. And in this case, the smaller activity is g of x. Now, according to this, g of x is 2x plus 3. So in case that doesn't make any sense at all, I am just going to kind of draw that right now. So if I want to know what f of g of x is, the bottom line is, again, since f is the larger context, that means it's going to be sine of some value. Okay, it's going to be sine of something, because that's what's happening here. It's the sine of some number. Well, we have that here. It's the sine of some number. But since it's a composite function, that number that goes in the parentheses is g of x. All right? And what is g of x? Well, g of x is 2x plus 3. So that's what goes in there. All right? So f of g of x, pardon me, is equal to sine of 2x plus 3. All right, so that's that one. That's actually the answer. All right? To f of g of x, which satisfies this part. But now we're going to have to satisfy g of f of x. And Paul, if you're watching this, I'm pretty sure that you probably understand what you got to do. But for those listeners who might not, we've got g of f of x. That's what we're looking to do. So that means that g of x, it's the g that's the overarching context. That's the big picture context of what's happening. The smaller activity is this f of x shenanigans. All right. So, since it's the g that represents the larger context, we're going to look to g of x and ask ourselves, okay, well, it's 2 times some number plus 3. All right, so g of f of x, that equals 2 times some number. So notice I'm doing this kind of, when I say some number, I leave an empty parentheses. All right, so it's 2 times some number plus 3. Well, what is that number? Well, it's f of x. That's the number. Okay, that's the number that goes inside. Well, what's f of x? F of x is sine x. So sine x goes inside there. All right, so that's it. That's how you do composite functions. Pretty straightforward. It's just a matter of understanding which function represents the big picture, larger context, and then drawing it with an empty parentheses, and then filling in that empty parentheses with whatever belongs in there. Okay, so that's all. That's that. And question, we've got express f as the composition of two functions u and g, such that f of x equals g of u, and u is a function of x. Alright, well that can be extremely confusing. It's like, what are we even talking about here? F and U and G and all this stuff. Well, basically, it's kind of a similar process, really, where they want you to express f as the composition of two functions. So what they're trying to say is that this whole thing, f is just f of x, all right? That's kind of shorthand notation for f of x. That's important to understand, all right? But basically, they just want you to show or represent this in such a way that you're showing that it could be seen as a composition of two functions. So in other words, this is already a composition of two functions, okay? Composition of two functions. It already is a composition of two functions. But the question is, what are those two functions that are being compositioned, for lack of a better word? All right. Now, the two functions, they want it to be u and g, such that it's g of u. Okay. So it's similar to the last problem we just did. G represents the overarching big picture context. Okay, G is the larger context within which U, the smaller context, is arising. Alright, so what that means is G, well first of all, G should be represented as just G of x. This is one of those problems where it's going to be helpful to kind of temporarily ignore this and just go off to the side and do some stuff and then return back to it. Alright, so we're going to go off to the side and do some stuff. We're going to figure out what g of x is, and we're going to ask ourselves what u of x is. Okay, because keeping in mind, just like how f is f of x, well when they say g, that really means g of x, and when they say u, that really means u of x. So it probably behooves us to find out, alright, well what's g of x and what is u of x? Well, once again, since they want the g to be the overarching context, you need to go here, and since this is already a composition, you ask yourself, what's the big picture of what's happening here? Well, the big picture of what's happening here is that there is some number that's being like square rooted, okay? It's the square root of some number. That's the big picture of what's happening here. All right, we're taking the square root of some number. Yeah, I know this is sine of x, but whatever, sine of x, it's just some number. It could be 25, I don't know. All right, well, actually probably not, but it could be any number, right? So square root of some number, okay? Well, that means that g of x is the square root of some number, okay? That's the big picture view of what's happening over here. The number that is being square rooted, in other words, the u that's inside the g of u, is this. It's the thing that's being square rooted, right? So in that case, it is sine x, like that. Okay, now I'm not sure exactly what your teacher's going to want. It's possible that this might even be sufficient, where you're kind of clearly demonstrating that you can see that f of x is kind of composed of two separate functions, right? But your teacher might want you to go further and do something where you kind of rewrite it like f of x equals g of u of x, like that. And then maybe even kind of do these steps where you're clearly demonstrating how to get from here to there. So in other words, the next step would be to be like, oh, well, what's u of x? U of x is sine x, right? I mean, at least according to this information, right? And then finally, the final, I don't know what the word is, the final move is, okay, well, what is g of blah? Well, g of blah is the square root of blah, right? So the final move is this. So by doing this kind of step-by-step process, it's in a sense proving that sine of x is indeed the result of a composition of two different functions. All right, so that's that one. Obviously, Paul, if you got issues with that, you can pause it, rewind it, whatever. It so happens that the next problem is very similar, so we're going to move. So next problem, exact same directions. Express f as the composition of two functions u and g such that f of x and g of u is a function of x. So I'm not going to spend as much time explaining the details of this one because you kind of get it from the last one. But nonetheless, we're just going to kind of jump in, you know. First step is to go off to the side and figure out, all right, what's g of x, what's u of x? So here I am going off to the side. G of x. Well, g of x, at least according to them, because g is on the outside here, g of x is the big picture of what's going on. So what's the big picture context of what's happening here? Well, it's the tan of some number. All right? This looks like a lot of gobbledygook craziness, but it's just a number. So the big picture is that we have tan of some number. So here we go, tan x. All right. And then you ask yourself, all right, what is u of x? U of x is the stuff that's inside the overarching function. Well, the stuff that's inside is this stuff. All right, so pretty simple. You just write that. All right, so that's that. And then if you want to do that kind of step-by-step proof, you could be like, all right, f of x equals g of u of x. And then the next move would be f of x equals g of what? Well, u of x, but what is u of x? U of x is 2x all over 1 minus x. And then the final move is like, all right, well, therefore, f of x equals, since it's g of this thing, well, g of something is tan of that thing. So we have tan of 2x, 1 minus x. All right? So that is that one. Exact same process as the last one. All right? It's possible that your teacher gave you this one, I don't know, maybe because it features tan or what have you. And it's like a trig function is the overarching function this time, which could be, you know, perhaps intimidating for some students. All right, so that's that one. And then finally we have this last problem, which is really two problems. So suppose the total cost in dollars of manufacturing Q units of a certain commodity is given by this whole ridiculous thing. All right. So we're going to take this one at a time, you know. We'll cross that bridge when we get to it. For now, we've got compute the cost of manufacturing 20 of these things. All right, well, Paul, as you probably know, this is a function where 20 units, the number 20 here represents Q, so that's the amount of things that we're manufacturing. And as you know, and a lot of people at home watching this know, functions are kind of like snack machines. Here it is. Here's the snack machine. Maybe there's potato chips in there, candy bars, whatever. But you're this person. This is you. You're standing outside of it, and you have a certain amount of money, we could say, or a certain amount of stuff that you put into the machine, and that's represented by Q. Now, depending on how much stuff this is, you put it in, let's say it's 3. Well, that means that 3 gets worked through the system, right? It goes through the whole mechanics of it, and then it ends up churning out a particular value, all right? So you plug in a certain value and it pumps out a different value. And in the case of a snack machine, maybe it's a candy bar, right? So that's the way that functions work in a sense. All right. Now in this case, what's Q? Well, it's the amount of units that you are considering or analyzing. C of Q is the cost of manufacturing all those units. So anyway, I think most of y'all understand that. So we're going to stick with the notation where it's like if we want to know what the cost of manufacturing 20 units is, well, that means we're looking for C of 20, the cost of 20 units. So we've got Q being replaced by 20 every time we see Q. Alright, so we're just going to do this. And I'm really hoping that my math is correct. You know, I hope I don't make any careless mistakes. Please forgive me if I do. But I'm just going to kind of do this on the fly. Now, most of you guys, your teacher's probably going to want you to keep writing C of 20, C of 20, C of 20 every step, but I'm just going to kind of save time and not do that. Just write the equal signs. So you got 8,000 minus 30 times 20 squared. That's 400. 30 times 400 is 12,000. And then 400 times 20, well, that is 8,000 plus 500. Okay, so you got 16,000 between these two minus 12,000. Well, that's definitely going to be 4,000. And that 500, so it's going to be 4,500, right? Okay. So I think that's right. Again, go easy on me if my math is wrong, and Paul, you could do this yourself. As long as you understand the general concept, obviously that's all that matters. And that, of course, brings us to the next part, which is compute the cost of manufacturing the 20th unit. Alright, so my thing is giving me problems. But anyway, yeah, so you get it. Here's the question that we're doing. Cost of manufacturing the 20th unit. So that could seem like an odd question. It's like, you mean it cost me a different amount to manufacture the 20th than it did the 19th? Well, yeah, as it turns out, in this function, the cost of printing each one is different. All right, so you might be used to like linear functions where the cost of everything is the same. Like, for example, if it costs me $10 to print a t-shirt, well, how much will it cost me to print 3 t-shirts? Well, that would cost me $30. The third t-shirt cost me $10 to print, and so did the second t-shirt. That cost me $10 to print as well. This is a function, because it's got these exponents, it's not like that. It's going to be such that, the first item is a different cost than the 20th unit. All right. But anyway, the way to understand how much the 20th unit costs is to compare the cost of the 20th unit to the 19th unit. And actually, you're going to want to find the difference between the two. Okay? So what we could say is the cost of the 20th, that equals, and I always like to start with the end in mind, right? Begin with the end in mind. Let's get the big picture here. That is the difference between C of 20 and C of 19. And I think you probably understand that. You know, when you manufactured 19 units, it was a certain total cost. And then when you did the 20th, it was like a different total cost. And the difference between these two is the cost of the 20th unit. All right. So if you don't understand that, just think about it. Rewind the video until that sinks in. But the good news is about this scenario is we're already halfway there, in that we already have C of 20. All right. So C of 20 is 4,500. Okay. And that leaves us in a position to find out what C of 19 is. And Paul, I'm pretty sure you could do this yourself, but just in the name of being thorough, I'm going to do it. Let's see. This is where we are right now. And you know what? I'm going to get fancy and break out some brackets. Bam. So we are looking at 19 cubed minus 30 times 19 squared plus 400 times 19 plus 500, and working that out on my calculator right now. Just gonna work it out right now, one moment. So after all that arithmetic, I ended up getting 4129. Okay. And that is this. Okay, so, and the difference between the two is 371. Again, probably some geniuses at home that calculated that in 2 seconds in their head. If so, good job. So we've got 371. And that is the cost of manufacturing the 20th item. All right, so that's it. Look it over, rewind it, do whatever you got it, and I will see you next week. Thanks for watching.